Continuing the section 2.4 notes, we now move on to example 2. Given the function g of t equals t squared minus 2t minus 3, evaluate the expression. Note that it may be helpful to think of the function as g of input equals input squared minus 2 times input minus 3. So the value of t is the value of our input, and the expression t squared minus 2t minus 3 determines what we might call the output. So A says to compute g of 0. This means t is equal to 0. So according to how our function is defined, we want to substitute 0 for t, 0 squared minus 2 times 0 minus 3, and simplify that. 0 minus 0 minus 3, and we obtain negative 3. So g of 0 equals negative 3. G of negative 2, part B. Here t is equal to negative 2. So using our rule, t squared minus 2t minus 3, this would be negative 2 squared minus 2 times negative 2 minus 3. You notice I'm using parentheses for this negative number, especially when I raise it to a power. And that's the way you should write it. Simplifying, this is positive 4, then plus 4, minus 3, which is 8 minus 3, which is 5. So g of negative 2 equals 5. Part C, g of a. Well, here t is equal to a, where a would be thought of as some unspecified numerical value. So g of t says you square t, you subtract 2 times t, then you subtract 3. In this case, t is equal to a, so we're going to square a, subtract 2 times a, and subtract 3. And that's really all we can do here, because we don't know what the value of a might be. So sometimes when we evaluate a function, we'll get an algebraic expression. We won't get just a number. So don't be surprised if that happens. That's going to happen if you don't have a specific numerical value given as an input. Part D, g of minus t. So here what we're going to do, and this is where it's helpful to treat t as an input, we're going to replace t with minus t. So we would square minus t minus 2 times minus t minus 3. So notice minus t replaces t. Minus t is the input. Minus t squared is t squared. Then we'd have plus 2t minus 3. Once again, we get an algebraic expression because a specific value of t is not given in this case. In part E, it's the same story. We're not given a specific numerical value. We're asked to compute g of t plus 1, where t would be some real number, unspecified. So t plus 1 would be the number 1 larger than t. What would g of t plus 1 look like? Well, t plus 1 is the input. So whatever the input is, you square it, you subtract twice the input, and then you subtract 3. So this would be computed as t plus 1 squared minus 2 times t plus 1 minus 3. Now we're going to try to simplify this, so we would like to take it further than this. First of all, t plus 1 squared. Let me just write this below here as kind of a separate step. If we square t plus 1, it's t plus 1 times t plus 1. It's not t squared plus 1 squared. You have to use FOIL. So it would be simplified or multiplied as t squared plus t plus t plus 1 using FOIL, first, outer, inner, last. That is t squared plus 2t plus 1. So t plus 1 squared is t squared plus 2t plus 1. It's not t squared plus 1. There's a middle term, 2t as well. Be careful with that. Then minus 2t minus 2, distributing negative 2, minus 3. Okay, can we simplify that further? Well, the 2t and the minus 2t cancel. And then the numerical values, 1 minus 2 minus 3, that simplifies to minus 4. So we would get t squared minus 4. And we can just leave it in that form. So again, we get an algebraic expression, but this, in this case, we did a little bit more in the way of simplification before we completed, got our final result. And then part F, the value or values of t such that g of t equals 0. So here we're solving for t, and we're told g of t equals 0. Now g of t is t squared minus 2t minus 3. So that's the same thing as saying that t squared minus 2t minus 3 equals 0. So the question would be, can we solve this equation? And the answer is yes, because, well, it's a quadratic equation. There's a variety of ways of solving quadratic equations, but this particular one can be factored rather easily. If we write down a pair of binomial factors, t being the first term of each, and then to get negative 3 you would need a 3 and a 1 with opposite signs. So if you make this minus and this plus, then the middle term will be minus 2t. You have to check according to FOIL to make sure that it matches the original polynomial. So this would be the correct factorization. I hope that that makes sense. If we then set each factor equal to 0, so if the product of the factors is 0, then each factor individually can be set equal to 0. We get t equals 3, or t equals negative 1. In other words, we're saying that g of 3 equals 0, and also g of negative 1 equals 0. So if t is either 3 or negative 1, the function will be equal to 0. I want to make one final comment about example 2, and it pertains to part E, g of t plus 1. I just want to make it clear, g of t plus 1 is not the same as g of t plus 1. This is a common misconception. In other words, students believe that to evaluate g of t plus 1, you just take g of t, t squared minus 2t minus 3, and add 1 to it, which would give you t squared minus 2t minus 2. But actually that's not what you get, as you can see. You have to understand that t plus 1 is replacing t. We're not adding 1 to the function. We're actually using t plus 1 as the input, replacing t. And that is dealt with differently according to the method I showed you previously. So just be careful of that, because that's something that's done incorrectly quite commonly. Next, we move on to considering the domain of a function. How to find the domain of a function given by, where the function is given by some sort of formula or equation. Given y equals f of x, we can define the domain of f to be the set of all real numbers x for which y is also a real number. we can think of the domain as a set of all allowable function inputs. In particular, we want to avoid division by zero and non-real complex numbers, for example, something like the square root of -1, which is not a real number. So basically, we're trying to determine what we are allowed to substitute into a function so that we'll get a real number output. And two of the things we especially look out for are division by zero and negative numbers under square roots. There are other things you sometimes have to consider, but for now, those are the two things that we really have to look out for. Let's look at example 3. State the domain of the function using interval notation. And our first example, f of x equals 2x over x minus 4. Notice that from the denominator, if x is equal to 4, the denominator will equal 0. So we definitely want to avoid any value of x that would cause the denominator x minus 4 to equal 0. And of course x equals 4 would be the only value that would do that. That's the only value that we have to avoid. Any other value should be acceptable for this function. Any other value will not give us division by 0. So the domain, which I'll just write as D, can be expressed as the set of all real numbers x such that, the vertical line is read such that, x is anything other than 4. X is not equal to 4. Now, we can write that in interval notation as follows. Well, first of all, let me write it this way. That's equivalent to saying x can be less than 4 or x can be greater than 4. So the set of all real numbers less than 4 or greater than 4. Now, the values less than 4 are expressed in interval notation as minus infinity to 4 with a parenthesis, meaning that the 4 is excluded from the set. X greater than 4 is expressed as parenthesis 4 to positive infinity. Notice the infinity symbol always takes a parenthesis. The or is translated when we write interval notation as union. So we're basically describing the set of all real numbers less than 4 or greater than 4, minus infinity to 4, union 4 to infinity. In other words, the set of all real numbers with one number left out, that number being 4. It's kind of an awkward way to write the set, but this is the way it's done in interval notation. I'm almost out of time for this video. I can only record for 15 minutes, so I will do the other 3 parts of example 3 in the next video.